Voracious, destructive, very, very dense. Black holes don't have the friendliest of reputations. They are by definition extreme. Their gravity is such that nothing, not even light, can escape them. But just how extreme can they get? Black holes form when massive stars collapse and die. Such stars can get really quite massive, up to a couple of hundred times the mass of our Sun. But the end of their lives is violent, and a lot of mass is lost in the process. So there are only a few solar masses worth of material left to collapse into the black hole, and most of the stellar black holes we know of have a mass of around 5 to 10 suns. But there are some outliers. For example, Cygnus X1, the first black hole to ever be detected back in 1965, weighs in at about 20 solar masses. But none are quite like BH3, the most massive stellar black hole ever found. It's quite close to us in astronomical terms, only about 2,000 light years away, but it wasn't easy to find. The thing is, black holes are, by definition, well, black, and they're mostly detected because of the radiation released by the material orbiting them. But BH3 is dormant, which means it's not actively accreting material that we can see. Instead, it was found using the European Space Agency's Gaia mission. Gaia found a star that showed an odd wobbling motion that could only be explained if the star was orbiting an unseen massive object, a black hole. Astronomers then used ESO's VLT and other facilities to verify the mass of the black hole and put it down at an impressive 33 solar masses. This is so massive that we're actually not sure how BH3 formed. Our best bet is that it originated from a primitive star, one that was more massive and less metal-rich than what we can find in our universe today. BH3 is impressive in stellar terms, but things get even more interesting when we look at supermassive black holes. These live in the center of galaxies, alongside hot, luminous disks of gas, which spiral inwards and are eaten. This is how black holes grow, and over time they can become truly gargantuan. One example is Sagittarius A star, the supermassive black hole at the center of our own Milky Way galaxy. But it's nowhere near as hungry as this beast. J0529-4351. It's the fastest growing, hungriest black hole that we know of, and it eats the equivalent of one sun every day. But don't worry, it's 12 billion light years away from us, so it's not going to eat us anytime soon. Its disk emits so much energy that it's 500 trillion times more luminous than the sun, and it weighs in at an incredible 17 billion solar masses, and counting. But actually, it's not the most massive black hole that we know of. Theoretically, the most massive a black hole can get is about 270 billion solar masses. Beyond this, the black hole will disrupt the disk of gas surrounding it, effectively starving itself. But how close can black holes get to this limit? And which one has stretched the laws of physics furthest? To be honest, we don't know actually. Measuring the mass of supermassive black holes is tricky business because we need to track the orbits of stars and gas very close to the black hole itself. No easy feat at distances of billions of light years. But we have some good candidates. One is Phoenix A. Belonging to the Phoenix cluster, it could well exceed 100 billion solar masses. This puts it in a new category altogether, called stupendously large black holes. Whoever named it must also be naming ESO telescopes. The problem is that its mass has been estimated using models, but never directly measured. Another possible record holder for which we do have a measurement is TON 618. It weighs an astounding 66 billion suns, and its disk is so luminous that we could observe it despite it being over 10 billion light years away. But neither Phoenix A nor TON 618 get anywhere near the theoretical limit for how massive black holes can get. But our knowledge of black holes is constantly growing, so who knows what amazing discoveries will smash these records in the next few years. Keep watching this channel to find out.